Welcome to RFID for Beginners++. And as my CEO pointed out, it's RFID for Beginners++, not RFID for Beginners++. Semantic differences, they're very important. So, 20 minutes turbo talk to cover the theory, the design, the operation, and the mathematics of RFID systems. Not gonna happen. This was originally supposed to be like a double talk, back-to-back, lots of content, and for some reason that didn't happen, and it came down to a 20-minute turbo talk. So, yeah, it's somewhat truncated. It was also supposed to include the design and operation of Cloner 2.0, which is a 75-minute presentation in itself, and yeah, that's not going to happen either. So, start out talking about what happened in DC and why I'm not giving a 150-minute presentation. Lots of legal nastiness. A certain company threatened patent litigation. ACLU got involved. Homeland Security got involved. US CERT got involved. Lots of legalese flying around about patents. Look it up on Google if you're interested. I won't repeat it all here. The upshot of it all was that we were looking down the barrel of potentially $10 million in legal fees to get a patent lawsuit dismissed that was completely baseless. And, you know, I don't care how elite you are, if you're a 30-man outfit, you cannot afford $10 million in legal fees. So we couldn't risk it, we pulled the talk. However, we've reached somewhat of an understanding now. We can now demonstrate the devices, we can talk about them, we can actually use them a little bit, but I can't give out schematics and I can't give out source code. And there is a certain vendor who will remain nameless throughout this talk, who I'm certain you can find out who it is if you don't know already. But yes, they will be nameless, completely. So, given that I've got 20 minutes to talk to you, I want you to imagine, if you will, that I've just delivered an eloquent, technical, desperately insightful presentation about how RFID works. About all of the theories behind it, how it's not an actual radio transmission, it's an inductive coupling. So if you think of it less as a radio transmitter and a radio and more like a transformer, you're right on the money. How, you know, the PIC microcontrollers are ideal for this kind of work because they've got lots of input-output pins, lots of capabilities, timers, all kinds of things that are great. You know, I've talked about RF modulations and amplitude modulations and FSK and FC810 encodings, and yeah, just imagine all of that. Also, imagine that I have explained in great detail that any 125 kilohertz proximity badge system is vulnerable. Indala, Motorola, Hitachi, others. If you are using 125 kilohertz proximity badges, such as this one, which you cannot see the logo from there, your doors are highly insecure. So, let me skip to the fun bit, the demo time. Toys! So, this was the first cloner. This was the one that I demoed at RSA, the one that got us into some trouble. And it's very simple. You push the red button. The red light comes on. That's in read mode. So you wave the card at it, and you see the green light comes on, showing that it's detected the card. And then in theory, if I kind of wave the card in the loop somewhere, the lights go out. It's copied the card. Simple as that. That's all it is. And then here, I've got completely standard USB RFID reader. It's not branded by anyone you would have heard of, but it was like, I think it was like 20 bucks from Radio Shack or something. So you swipe the card across it, light goes green, code comes up. Very simple. Throw the card away. Take the cloner, push the black button, swipe the cloner. Light turns green, code comes up. We've copied the card. Thank you. So, the other things that this can do, if you actually push both buttons, it commits the code to flash memory. So if you need to change the battery or do something else, you can do that, and then you put the battery back in, and you can still, eventually, hopefully, replay the code. So, big problem with this one. This was designed as a teaching tool. This was designed for Black Hat DC so that I could pick it apart and explain everything about how it works. So it's very, very simple. Enter Cloner 1.1. This is basically the same circuit. This is a development board though, so it's kind of messy on the flip side, and yeah, there's no box around it, but essentially it's the same circuit. I've just taken a lot more care over tuning the various components in it. The RF stage is much better. There's a bit more power going through the coil. It's just overall slightly tweaked. And the great thing about this one, let me put it here so I can kind of show you. If I put this one into read mode, move that away, it confuses it. Oh, through that kind of far. I don't know if you can see the green light from there, but the green light comes on at much greater range, and it reads the card from much greater range. So you've got a good few inches of range on this one. It's not quite that you have to kind of fumble with someone's pocket and they wonder why you're groping you in an elevator. You literally can. With this, it's the same circuit, it's just slightly tuned, and it's got much, much better range, a good few inches. So that's Cloner 1.1, and again, I'll do it the other way around because the circuit's a bit fragile. If we push the playback button and then swipe the reader, again, it plays it back. So it does exactly the same thing. So, yes, I wasn't lying. I have built RFID cloners. No, it wasn't faked. Despite statements made to the press by certain nameless vendors, it was not staged. Another interesting point to note. Anyone seen these things before? RFID shields. Like tinfoil wallets and little flippy open case things. The idea is, you take your card and you put it in a tinfoil wallet. Now these are actually commercially produced. These are from a company called Identity Stronghold. We've been giving these away at our booth. These are FIPS approved. They're government certified. They are as good as it gets in terms of RFID shields. Light turns green, code comes up. So let's scrap that idea, skip back a few slides, go back to Notepad. So this one, this is the premium version. So you put that in there, and the idea is when it's closed, you can't read the card. When it's open, you can read the card. So we'll leave it firmly, in fact, we'll hold it closed, firmly closed. Bugger. The problem with it is, when you're talking about 125 kilohertz, you're talking about a lot of power. It's extremely difficult to filter it. You really cannot block it. The company that makes these things, I was on the phone to their CEO the other day, and he said to me, look, you know that these don't work at 125 kilohertz, right? I was like, yeah, so what does? He's, well, I don't know. We haven't figured that out yet. They're working on an active device that will generate a confusing signal. It'll effectively jam it. So you'll have a second device in your pocket with, a 125 kilohertz emitter that's actively kind of fuzzing the spectrum, trying to prevent people from reading your RFID. It's wrong. Just scrap the stuff. Just get rid of it. Anyway, these things, they're great at higher frequencies. If you're up in the megahertz range, which most of the newer RFID stuff is at, they work fabulously. So we've still got a whole bunch left over. Hopefully someone from IOActive will take the hint and run up and get some and have them by the door when we leave. Yay! Thank you, Damon. So yeah, higher frequencies are great. So they're great for credit cards. They're great for everything except 125 kilohertz procs. It's bad. So yeah, we've improved the range on Cloner 1.0, so we're at kind of 1.1 at the moment, and we're still going. Cloner 2.0 is in development. Unfortunately, billable work is kind of necessary sometimes, so the RFID research kind of got put on the back burner a little, given that I only had 20 minutes to talk about it as well. So some things that it's kind of doing but not quite properly yet. Significantly improved read range even from this. It'll read cards about here. So it's a pretty decent read range. It's got multiple radio front ends. So this particular brand of card that's now over there somewhere, it's 125 kilohertz, but there's a lot of other different ways of modulating the data onto that 125 kilohertz carrier. So it's got multiple different decoders, demodulators at the front end, so it'll also read Indala tags in addition to the cards that with the tag that you can't see the brand from there. So it's also got an enhanced microcontroller, so it's got much more capabilities in terms of finding the data format. If I get sufficient energy to do it, I might even put in a brute force mode, because the card IDs in these are actually incremented. They're sequential. So in theory, you can grab one badge number to get into the building, and then if only certain badges within the organization have access to the server room, you can just brute force it. It's not difficult to do, really. Another fun thing that Cloner 2.0 is doing, it has a passive mode. So what primarily limits the range of these readers is the fact that this coil on the reader needs to power the card. So there's fundamentally a lowest threshold of power that you have to have. So either you're putting out so much voltage through this coil and so much power that it's getting dangerous, or you let someone else power it. So the idea would be, you take Cloner 2.0, drop it in a bush by the back door. Someone comes along, scans their card. Oh, stop it. Someone comes along, scans their card, the reader provides the power, and I just get a very, very small signal that I can amplify up significantly and recover the codes. So, as I say, drop it in a bush, come back a couple of days later and recover all the codes that, for everyone that's gone in and out of that, or gone in the door at least, for the time it's been there. Aiming for 10 feet range on that. Might not get there, might be better than 10 feet, but that's what I'm shooting for. So, reading RFID tags passively at 10 feet distance. It'll also have a display and keypad for the retrieval and entry of codes, so you don't have the ability to just store one code in Flash. You can put them in and read them out at will. Hopefully it'll be ready for Black Hat 2008. Anyway. You can have schematics? No. Bad people. All of you people who've been asking me for schematics, stop. I cannot give out schematics. However, Jonathan Westhuse, he built a Verichip cloner. And strangely, his circuit looks remarkably similar to this. In fact, coincidentally, he actually uses the same PIC microcontroller. And he also has 2 buttons and 2 LEDs and a couple of transistors, and has some things in common with mine. The main difference with the Verichip cloner is it uses a different modulation scheme from these nameless cards. So that's a good basis for the framework of the cloner. The third link down is a microchip reference design for an RFID reader. So the guys that make these microcontrollers actually said, hey, if you want to make an RFID reader, here's how to do it. Here's the schematics. Unfortunately, their circuit is kind of ugly. It's inefficient and uses way more components than it needs to, so it'll work, but it's going to cost you a bit of money. Maybe $12 instead of $10. So basically, if you take those two and spend a week on it, if you've got the kind of high school level electronics, those two will be enough for you to build this device. The protocol documentation is also public, and yes, I'm right in saying that none of those links mention the name of this vendor either. Superb. And then the data sheet. When I was building this, the hardest thing that I found with it was getting the PIC in the right mode, because it has a million different flags to set up a million different things in it, and unless you get precisely the right combination of exactly what's going on, it just won't work. So get the data sheet, print it out, bind it in a folder, use it. So, as I say, those links, high school level electronics, and a week of your time, and you'll have an RFID cloner of your very own. If you understand nothing beyond V equals IR, then it might take you a month. It's not a complicated project. It's really not. So, first off, let me say that I can answer technical questions over email. If you need some help understanding things, I cannot give out schematics. I cannot give out source code. I can give you schematic fragments. I can give you source code fragments. So if you ask me to build you a cloner, I can't do it. If you ask me to tell you what's wrong with your cloner design, I can do that. And then, just as a little bit of fun, turned out that after Black Hat Federal, I was left with 300 Black Hat CDs with an illegal presentation on them. What do you do with 300 Black Hat CDs when you live in Pennsylvania and you got 4 acres of land and your brother-in-law's a gun nut? Would anyone like to see what a 30-06 round does to 150 Black Hat CDs? You ready?
Yep.
Whoa! Very satisfying. Believe me, that felt good. Also, we took 150 more of them and attacked them with a 12-gauge shotgun. Surprisingly less effective than the rifle. And then,
nice.
My brother-in-law is not a redneck, really. So, and then, because at some point the string broke and there were still CDs left everywhere, we had to finish them off. And to me, putting things out of their misery has to involve a 45.
Ready? Yep.
I had fun that day. So actually, can I ask, is Jeff Moss in the room? Jeff, are you here? Okay, because I actually have a souvenir for him from Black Hat DC. I don't think it would play, but I think it would look quite good in a frame. But if anyone sees Jeff, come tell him to collect his very special award from me. So yeah, that's about all I've got. Any questions? Yes.
Is the coil on the device detuned at all by being near your body if you were to say wear it in your sleeve?
It is a little, but not enough to throw it off. I can demonstrate it if I put the whole thing on my arm. So not only am I getting interference in the inductance of the coil, but I'm also getting interference with the contacts on the back here, touching my skin. It stops working completely, actually. There we go. So yeah, if I have my hand in the coil like this, and I can take my card, and it'll still read quite happily. It's actually getting thrown off by the reader at the moment. So it will still read quite happily, and I can have the coil over my wrist, and I can read it again, and it's pretty good. You can tune it much better, but the problem is that the finer you tune it, the higher the Q factor of the resonance circuit, the narrower the bandwidth becomes. So it becomes more sensitive to interference from hands and bodies and other bits of circuitry. So yeah, you can do it. I made a particular design decision to do it this way because it had nice high bandwidth and reasonable read range. But yes, you can improve it like that way. Yes? No. Common misconception, it's not radio. It's radio frequency, but it's not radio. It's a magnetic field. If you think of it more like a transformer than a radio transmitter, you're on the right track. So there are ways of concentrating it. You can use like a block of ferrite material, and that'll concentrate it. But you can't put kind of a directional RFID antenna on it. You can't put an RFID Yagi in, effectively. Yeah, the basic idea is to put as much power as you can through this coil and have the receiver as sensitive as possible. It does get dangerous, though, because this whole circuit runs off 5 volts, which it switches through the coil. When it comes out of the coil, it's working at about 100 volts. So you can imagine, if you have a coil this big, such as I was considering building for Black Hat, so that we could have an RFID wall of sheep, You walk past, your badge number just appears. Considered it, ran the numbers, decided that I didn't really want bare circuitry holding kilovolts at Black Hat. Just kind of seemed like a bad idea. I'm sorry? Yes.
I know it's not radio frequencies, but if there was another carrier, say like some other radio transmission, would it show up as spikes or noise on that transmission?
Yeah, I can actually demonstrate that. Yeah, absolutely. So I've got a reader here and a cloner here. So this is actively putting out 125 kilohertz radiation so that it can detect the cards that come near it. And if I put my cloner into read mode, you can see the green light is flashing, and it's affected by this reader. It's picking up the interference from this device. And when this is anywhere within range, it just won't clone it. Yeah, it doesn't want anything to do with it because there's just too much noise coming off this. So yes, they are susceptible to noise, but it's magnetic noise rather than electromagnetic noise. Did I see a hand over here? No? Any more questions? Oh, yes.
Can this be designed to be changed to do the writing as well, or do you just have to take the device itself as well?
Well, the idea is that virtually all of these cards are reprogrammable, but why bother? It's more work. It's just as easy to use this coil to read the card and then use the same coil in the same circuit to play back the code. It's actually a very, very trivial change to the way that you're operating the coil. And it's very easy to do. It's not complicated to use the same circuit to read and play back. So yes, you can reprogram the cards to have your own IDs in them, but it's an unnecessary complication. Although it would be an interesting publicity stunt. A lot of the Verichips are essentially the same as the pet tags that you get implanted in your cat's neck, so if it runs away, it can come back. A lot of those are reprogrammable. So I did actually consider a publicity stunt where I'd reprogram one of these chips with a badge number and adopt a kitten from a local animal shelter and then, break into the California Senate building with a kitten. It can be done. It can be done. I'd quite like to see the Homeland Security advisory that goes around about that. But yes, it can be done. Question at the back.
From a pen testing perspective, the ability to hide the device from something else, other than packaging cigarettes or something along those lines, would you be able with 2.0 to be able to make the antenna smaller, make it a little more compact?
Yeah, the only reason, and I do mean the only reason why the antenna is this size, is if you notice, it just happens to be the same size as a CDR box. Just because I was looking in my office for something that I could use as a coil form, and I thought, that'll work. You can make the antenna as big or as small as you like. One thing that I've been considering doing is putting a coil in the frame of a card holder on a lanyard. So you'd have like a fake printed badge, and you'd have the coil from the cloner in the frame of the lanyard with a wire running up your neck to a box in your pocket. So you actually swipe the badge, and it reads the coil in the frame of the badge, and it reads it like that. Yes, it's absolutely possible to make the coil as big or as small as you like, subject to some physical limits, but you can get it extremely small if you wanted to. Any more questions? Yes?
A smaller coil, different effectiveness as far as
Probably, but not significantly because you can compensate for it by just adding more turns to it. You'll have to be careful that the circuit's still appropriately tuned, but yes, you can compensate for it. It's not a major hurdle. Over here. Let me put it to you this way. If you were to name the 10 biggest sites on the internet, I've probably had dealings with at least 4 of them. Every single one of them uses this exact technology from this exact vendor. It's common as muck. I have yet to encounter someone that uses something other than 125 kilohertz. I've seen people using Indala instead of those who shall remain nameless. But it's fundamentally the same technology, and it's just as vulnerable. It's just a slightly different modulation scheme. So as far as I'm aware, everyone uses it. When I gave my presentation in DC, I actually asked people to raise their hands if they were using either something other than 125 kilohertz procs or a second factor of authentication, like a PIN pad or something. And I believe that there were 3 hands went up in the audience, one of whom was the vendor in question. Any more?
Is that a comment?
Yeah?
You mentioned cloning via the rewritable chips, and Adam Lori gave a talk earlier, which he wrote software to do with RFID.
Oh, okay.
And you can turn the PET chip into the Vera, what's it called?
Verachip. The PET chips and the Verachips are basically exactly the same. The only difference is about 10 bits.
Country code is four places instead of 3.
Yeah, something like that. It's very, very similar. Yes?
To prevent having the reader of the bush near my point of entry with the RFID system, can I actively transmit noise that will prevent you from reading that everywhere outside of, let's say, a half inch from my reader?
In theory, in practice, it's going to be very difficult so that it's effective against sniffers in the area, but not against your actual reader. In theory, you can do it. In practice, it's going to be very difficult. So, well, I think that's all the time I have, so I'm going to vacate the premises now and just be impressed that I wasn't sued. Thank you very much.